Hello class, today we are looking at equilateral and isosceles triangles. Still looking at congruence and are triangles congruent and what can we do with that. Today we're specifically looking at equilateral and isosceles. And really we're more looking at isosceles than equilateral, but that's right. Now, isosceles triangle, just quick definitions, y'all already know this, but just to refresh yourselves. This is a triangle that has at least two congruent sides. All right? That means if it has three congruent sides, like an equilateral triangle, it's still isosceles. So everything we talk about that's true for isosceles triangles is also going to be true for equilateral triangles because they are isosceles. All right? So we've got at least two congruent sides, and those two sides that are congruent, we call those legs. Alright, just like the two legs of a right triangle are the ones that form the right angle. Here, isosceles triangles also have legs, and these are the two sides that are congruent to each other. Alright, and the two sides that are congruent to each other, the legs form the vertex angle. Alright, so this is the vertex angle. The side that is not the legs, that's called the base. And the base has the base angles. Those are the angles that are there adjacent to the base. The angles by the base are the base angles. Easy enough to remember. Now, we want to make sure we point all of that out because we have a theorem that specifically talks about the base angles. That is the Base Angles Theorem. All right. What the Base Angles Theorem says is that if two sides of a triangle are congruent, then the angles opposite them are congruent. So here we have the two legs of this isosceles triangle are congruent, because it's isosceles. And what this says is that the angles opposite those legs are going to be congruent. All right? And the angles opposite the legs are the base angles. So we call it the Base Angles Theorem. So that means that since AC is congruent to AB, then angle B is congruent to angle C. They're opposite each other. They're congruent. Then we have the converse of the Base Angles Theorem. All right. If you remember, converse just takes things and turns them around, go the other direction. So instead of saying, hey, if the legs are congruent, then the angles are congruent, what this says is if you have a triangle with two angles that are congruent, the sides opposite those angles are going to be congruent. So since we have this, we have base angles congruent, that means that segment AC is going to be congruent to segment AB. All right, so since I have two congruent angles, that means I'm going to have two congruent legs, and this is going to have to be an isosceles triangle. All right. All right, so Base Angles Theorem says that if the legs are congruent, the base angles are congruent. The converse says if the base angles are congruent, then the two legs are congruent. The two sides opposite those are congruent. Then we have corollaries. And if you remember, a corollary is something that can be proven really quickly from the original theorem. So the corollary of the Base Angles Theorem says, well, if a triangle is equilateral, then it's equiangular. So if all three sides are congruent, then all three angles are congruent. Because if these two are congruent, then these two angles are congruent. And if these two sides are congruent, then these two angles are congruent because they're opposite those sides. So that means all three angles are congruent to each other because all three sides are congruent to each other. All right. And then we have the corollary to the converse of the Base Angles Theorem, or the converse of the corollary of the Base Angles Theorem, whichever way you like it. And what this says is if it's equiangular, then the triangle is equilateral. So if these two angles are congruent, then the opposite sides have to be congruent. And if these two angles are congruent, then the opposite sides have to be congruent. And so all of the sides are congruent because all of the angles are congruent. All right. So if all the angles are congruent, the sides have to be congruent. And if all the sides are congruent, the angles have to be congruent. So easy enough. Not a big deal. Let's take a look at this, see what we can do with this stuff. All right. Answer some questions, that kind of thing. All right. So what we have here on, let's move the paper so we can see, there it is. So 1 through 4, we want to complete the statements and then state which theorem was used. Okay, so we're looking at this diagram here. We have Segment NJ is congruent to segment NM. So let's see, segment NJ is right here, segment NM is right there. So segment NJ, I'm going to go ahead and mark it, is congruent to segment NM. Okay, so the question is, which two angles will be congruent? Well, we have NJ and NM, so we're looking really at triangle NJM, all right? And we have two segments that are congruent, so two sides of the triangle are congruent, which means what? Well, if two sides of the triangle are congruent, then the angles opposite those two sides are going to be congruent. So, let's see where we go. These two sides are congruent, which means the angles opposite in this big triangle NJM are going to be congruent. So opposite of MN is going to be angle J. So I'm going to put angle J. Opposite of NJ, coming across here, is going to be angle M. Angle M. Now we do need to state the theorem. So which theorem was that? That was that very first one. That was the base angles theorem. So that's what we're at. Base angles theorem. Base angles theorem. All right, let's take a look at this next one. Let's change colors. If segment LM is congruent to segment LN, then which two angles are congruent? So let's see, LM, so LM, that's right there. Congruent to segment LN. I'm putting two tick marks on these so I don't get them confused and think they go with those ones. Alright, so which angles are congruent? So looking at this, we have LMN. This is the triangle we're looking at. And again, we have two sides congruent, so the angles opposite those two sides are going to be congruent. So that means opposite of LM is going to be angle LNM, this angle right here. So angle LNM. And opposite angle LN, opposite that is going to be angle M, right there. Angle M. And we could call it angle LMN, but since it's the only angle we have there, we can just call it angle M. Okay, and how do we know this? Well, again, because the sides are congruent, so the angles opposite the sides are congruent. That's the base angles theorem. We just used that, so we're going to use it again. This is the base angles theorem. And there it is, abbreviated for those of you who like to write things shortly, because you don't like to spend a whole lot of time writing things, and you don't have to worry about, spelling. All right. Number 3. If angle NKM is congruent to angle NMK, then what else is congruent? So let's see. NKM, so NKM is going to be this angle right here, congruent to angle NMK. So that is this angle right there. All right. So let's see, we've got two angles congruent. We need to figure out what else is going to be congruent. Well, let's see, what happens if we have two angles of a triangle congruent? Let's see, two angles of a triangle are congruent, then the sides opposite them are congruent. That is the converse of the base angles theorem. We just had that. So, the sides of the triangle opposite these two angles. So, we are looking at this triangle right here, triangle NKM. So opposite angle K is angle or side MN. So segment MN is going to be congruent to, let's see, opposite angle M is right here, segment NK. Because we are in this triangle right there, in that triangle. Okay. Let's take a look at number 4, our last one. Oh, wait, we didn't state our theorem. This was not the base angles theorem. This was the converse to the base angles theorem, because this one started with the angles. So, converse to the base Angles Theorem. All right. Okay, next one. What do we got here? We've got angle LJN is congruent to angle LNJ. Then what is going to be congruent? So let's see here. LJN. So that's going to be this angle right here. Congruent to angle LNJ. So LNJ. That is going to be this whole thing right here. Okay. So we are looking at this triangle down at the bottom. It's bottom half of this. And so the side opposite the angle is going to be congruent. All right? Because we have two congruent sides. So the sides opposite those two congruent angles are going to be congruent. So opposite angle LJN is going to be side LN. So segment LN is congruent to, let's see, opposite angle LNJ is going to be over here. That's going to be side LJ. Side LJ. How do we know this? What theorem did we use? Again, we used the converse to the base angles theorem. So let's see here. I'm going to abbreviate this time. Another way you may see this is the base angles theorem converse. Like so. That's another way you may see it abbreviated depending on how it shows it in your textbook. All right. Okay, so there's that. That's not too bad. All right. Two angles are congruent. The sides opposite those angles are congruent. Two sides are congruent. The angles opposite those two sides are congruent. So let's take a look at 5 and 6. This wants us to find the value of x. All right, so x is over here. It's one of the sides. We do have another one of the sides. It's not a right triangle. You can't do Pythagorean theorem or anything. But, oh, we have congruent angles. All right? And in fact, since all three of these angles are congruent, we know that this is actually an equilateral triangle. Right? That was the corollary to, I believe this was the, corollary to the converse. Right down there. If it's equiangular, then it's equilateral. So this is equiangular, so it's going to be equilateral. All of these sides are congruent because it's an equilateral triangle, which means this length is the same as that length, and so x equals 31. That was pretty easy. That was good. All right, let's take a look at the next one. What do we have here? Hopefully it'll be just as easy. All right, this time we're looking for an angle. It doesn't give us any of the other information about the angles. It is a triangle, though, and so we do know all three angles add up to 180 degrees. All right? But that doesn't help us if we don't know what the other two angles are. So let's look at the sides. If you'll notice, all three sides measure 12 units, which means this is an equilateral triangle, right? And as we saw over here, the corollary to the base angles theorem says that if it's equilateral, then it's equiangular. So that means all three of these angles are the same, right? And they all excuse me. So they all add up to 180. They're all the same. So this 3 times is 180. So a couple ways we could do that. Easiest way to do that is 180 divided by 3. So 180 divided by 3 is 60 degrees, which means this angle right here is 60 degrees, and so are the other two because they're equiangular. And so we know that 2x equals 60 degrees because this is 2x and it's also 60 degrees. Divide by 2, and so x equals 30. Okay. So there it is. That wasn't too bad. Not too bad. Okay, so let's take a look over here at numbers 7 and 8. Here it gets a little bit trickier. So we need to find the value of x and the value of y. And looking at this, we've got a couple of things going on. We've got x right there. This is the length of this side. Y is the measurement of this angle. And then we have y minus 25. So looking at this, what do we notice? What can we use? Okay. Well, we see here we have an equilateral triangle. So all of these sides are the same, y minus 25, whatever that is. Okay. Can we use that to find x? Well, it is side. This one is, here we go. These angles are the same, right? So since we have two angles in a triangle that are congruent, that means the sides opposite those angles are also congruent, which means that this side here is going to be congruent to that side there. So that means all of these sides are congruent, so x is also going to equal this y minus 25, whatever that is. So I'm going to go ahead and write that down. X equals y minus 25, which will be, it would be a bigger help if I knew what y was. So let's take a look at y. Here we have y all by itself. So it's an angle, so let's see what we can figure out about our angles. Okay. Let's see, these two angles are the same. So if I know what this one is, I can subtract it from 180 and figure out what these two are, because they're the same. But I don't know what that is. Well, I know this whole thing is a right angle. So if I could figure out what this one is, I could subtract this from 90 to figure out what this little piece right there is. So let's see, what is this? We have, this triangle is equilateral, which means it's equiangular, and we just figured that out. If it's equiangular, the measurements are going to be 60 degrees. All right. So that means this is 60 degrees because I have an equilateral triangle. And this is 60 and it's equiangular, so this is 60 degrees, and so this is 60 degrees. Which means this little bitty angle right here, I can take the 60 from the 90, and yeah, I know that's 30, but I'm going to write it down anyway. 90 minus 60 is 30 degrees. Right here, I've got 30 degrees. Okay, so now I need to find out what y is. Well, I know that all three of them together are 180, so angle y plus this other angle that's congruent to y, so also y plus 30 is going to equal 180 degrees. Subtract 30 from both sides, minus 30, minus 30. And so I have 2y is equal to 150. Divide by 2 to both sides, and y is equal to 75 degrees. 75. So there we go. I now have y. Now that I have y, I can figure out what x is. Alright, so x is equal to y, which I now know to be 75, minus 25, and so x is equal to 50. And there it is. So that one did take a little bit more work. I had to think about that one. So not quite as easy as those first two. Let's take a look at number 8. All right. Actually, go ahead and pause the video, see if you can work out number 8 by yourself, and then come back. Let's see how we did. Number 8, we need to find x, we need to find y. So let's see, we have x is this angle all by itself over here, so that might not be too bad. Y, you have 2y plus 10 there, and we have x minus y over here. Now let's see, what do we have that is congruent that we can set equal to each other? Well, we have these three sides congruent, so we've got an equilateral triangle there. That can be useful. So that means that these two are the same. And we'll go ahead and put that right here. So 2y plus 10 equals x minus y. Doesn't help me until I figure out what x is. Okay, so x is here. Angles. Well, I do have one of the other angles in this triangle. So that's 40. So 40 plus x plus something is going to equal 180 if I know what that something right there is. And if you look, I have congruent sides. This is an isosceles triangle, which means base angles are going to be congruent. So this angle right here is going to be congruent to that angle over there. So if this is x degrees, that is also going to be x degrees. So I can work this out. I have x degrees plus x degrees plus 40 degrees is going to equal 180 degrees. because that's the 3 angles of my triangle. So we subtract 40 from both sides, and I have 2x is equal to 140 divided by 2, and x is equal to 70. Alright, so now I know what x is. Now I find y. So I'm going to take my 70 and I'm going to plug it in right there. So I have 2y plus 10 is equal. 2y plus 10 is equal to 70 minus y. Okay, so now I just have to solve for y. This is easy enough. I'm going to add y to both sides. I'm going to move the 10 over here, so minus 10, minus 10. Right, so that cancels out, and I have 3y is equal to 7 minus 10 is 60 divided by 3, and I end up with y equals 20. And there it is. So that is not too bad. All right, that's actually pretty easy stuff right there. I need to grab this over here. Thank you. Okay, so not too bad. You got to look at which sides are congruent, and that's going to give you angles that are congruent. And from there, you can hook stuff together, figure out that this is congruent to that, congruent to that. Over here, help us get this congruent to this, to congruent to that, so everything goes together. All right. Now, real quickly, I'm going to show you one more thing. I am going to show you how to construct, using a compass, how to construct an equilateral triangle. Okay, this is really easy, and it doesn't take a whole lot of time, so I'm going to go ahead and do that real quick. So first, let's say we'll do one 3 centimeters in length. Okay, so each leg is going to be 3 centimeters long. So I'm going to draw me one side 3 centimeters long. There it is. Okay, now I need 2 more that are 3 centimeters, but where do I put it? Right here. Do I put it here, here? How do I know that exactly what it is without measuring it? Because I don't really want to use a protractor because I'm not very good with those. So what we're going to do, we are going to set the radius on our compass to 3 centimeters. So start it right here at the crosshairs, and right there on the other end of my thing, right? 3 centimeters. And I'm just going to draw an arc going up that way. Every point on this arc is 3 centimeters away from this vertex. Now I'm just going to take it, turn it around, and I'm going to draw another one. Right here, don't change my settings because I still want it to be at 3 centimeters. And draw another one on that side. Every point on this arc is 3 centimeters away from this one. The intersection right here, all I'm going to do is connect that. And I connect it right here. And there it is, equilateral triangle. And draw very good. Equilateral triangle, 3 centimeters, and 3 centimeters. All right. Just something else, little freebie. Okay. So, equilateral triangles are isosceles triangles. And remember, if 2 sides are congruent, the angles opposite the sides are congruent. If 2 angles are congruent in your triangle, the sides opposite the 2 angles are going to be congruent. If you have all 3 of them congruent, then all 3 of them are congruent. So there it is. And hopefully you found that useful. Hopefully it helped. And I will see you next time.